Hi friends, welcome to my channel. Let's continue on explaining problem 2571, minimum operations to reduce an integer to 0. In the previous video, we explained a solution based on bit manipulation. And in this video, we're going to share a treatment which basically based on sort of greedy idea. So here the treatment is that we always subtract nearest power of 2 from the number n. So in this video, I'm not going to reread the problem statement and the problem examples. So here we want to directly begin with the treatment. So here first thing, I want to put this solution to be more rigorous. Notice that the union of intervals of this format, so I'm using the left is closed and the right is open. So this is the left closed and the right half intervals. So this form 2 to the power I minus 1 and 2 to the power I for I greater than or equal to 0. So the union of this kind of integers actually cover all positive integers, right? So then, because of this observation or this simple fact, then for each integer m, there exists some fixed index I, such that n is in one of such intervals, right? So for example, we can assume n is greater than or equal to 2 to the power I, less than 2 to the power I plus 1. And then we shall subtract either 2 to the power I or 2 to the power I plus 1, depending on which is near to m, right? So in order to measure how far or how near a power with respect to n, we can consider the absolute value. So if this absolute value, that is the distance between n and 2 to the power I, is less than or equal to, so the 2 is actually a tie case, we can subtract either. So then we're going to do n minus 2 to the power I, right? So in this case, this n is still positive, right? Because 2 to the power I is smaller. Otherwise, so we're going to do n minus 2 to the power I plus 1. And in this case, n will be negative. So the positive case, we just continue the process. And then the latter actually makes n negative. So we can write n equals negative k, where k is positive. So then the next step, so we still consider this kind of operation, add or subtract a power of 2 from m. So we want to make it near to 0 in distance. So we need to add smallest power of 2 to make the updated number, that is negative k, non-negative, right? So we want to add 2 to the power j, so to make it greater than or equal to 0 for some proper j. So this procedure is equivalent to do k minus this number, right? So this will make this this guy so here we consider put a negative sign, so it's going to be negative parenthesis k minus 2 to the power j, right? But this guy is positive. Then just we consider this one, then we consider the absolute value. So this is the same effect, right? So to sum up, while the number n is not 0, we always do the following. So we subtract the nearest power of 2, say 2 to the power I from m. So the subtraction makes the resulted number either positive or negative. And then we update m by this. So the n to be the absolute value of n minus this power, right? So this way, actually, in the procedure, we could use a counter to count so the number of operations needed. So that's the logic here. So here we used a very simple mathematical reasoning. So this is actually, so if you have some background in mathematics, this is so I would say rather straightforward. So with that said, we are ready to write a solution based on this strategy, right? So here first, given this n, I'm going to first get the corresponding number list, power list. So we cannot make the power too large, right? So here, let me get this power 2 list. So we can use list comprehension. So let's write in some fancy way. So this shift to the left, I unit. Actually, this is nothing but 2 to the power I. So, but let's write this for comparison with the bit manipulation solution in the previous video. So for I in range, so we can start from 0 because 0 corresponding to the power 0 is 1, right? Then we end at this integer of n to the power 0.5, right? So we can plus 1 or plus 2. Let's plus 2 for safety, right? And then we get this one. So these powers are the powers actually come into play in the problem. So here I'm again going to use a result variable to for counting. So this is for counting the number of operations, right? And then also I'm going to, so each time I want to select the nearest number from this power list and to the n, right? And then we subtract that one, and then we do the update. So in order for do the comparison, right? So I'm going to initialize a difference variable. Let's call it diff. To be first, we can use it as float infinity. It's very large, and then we are going to iterate. So here, well, n is greater than 0, right? What we are going to do then for p, let's see, power 2 in power 2 list. What we are going to do? So here we compute the absolute value of this p2 and this n. So if this difference is smaller, right? So if diff is smaller, then what we are going to do? We are going to set diff to be abs p2 minus n, right? And then we are going to update this n. So this n will be the diff. So this will be the update, right? Now each time if we make a subtraction, so this procedure corresponds to let's see, this is pick the nearest power of 2 from the list, and then this one reset or update on n, right? N will be the n minus the nearest one. That is the smallest difference we get. So after this, so because each time we need we do this operations, so this is one operation, right? So one subtract or subtract, right? So we're going to increment this result by 1, and then finally we do the return, right? So this short code forms another solution format for this problem. So I guess before we make some optimizations or comments, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So this is actually a longer format. So because in this one, here we initialize this variable and then make so essentially we linear scan the list here, right? So this list basically length is of n to the power 1/2, right? Square root of n. So let me copy this part and then change this one to be v1, and then I want to slightly simplify this problem a little bit. So here I do not need this one, and what we are going to do here is to get the nearest power to n, right? So for this, actually we can do this nearest. So we can do a min operation. So we get so we are going to this is the iterable or list we're going to consider, but we do not do the Euro comparison. So let's specify a comparison key. So here the key will be a lambda function. So here I'm writing an anonymous function. So basically measures the difference between the given n, right? So here we give an element in this list. Let's call it p2, right? Because it's power of 2. And then we're going to map it to p2 minus n. This is the absolute value. So essentially we are doing the same, but we use this compact format, right? So once we get this, then what we're going to do, so we are going to update this n, right, corresponding to here. But because previously we have introduced this variable difference, right? So the update will be the difference itself. Here we just need to consider the ABS of nearest n minus the nearest. And then once we do this subtraction and then do the update, we need to update the counting by 1. Now let me do this, and then this actually shortens this v1 a little bit, but essentially the same code. But you know, it's always good to know we can use a comparison key to the min or max function, right? Similarly, like you customize a sorting key tailored to your specific needs or problem. So here is an example. So now with that done, we are ready to do a test for this solution format. Yeah, it passes the first example. Now let's look at the generic case again. Yeah, it passes all the generic cases. I guess with this done, that's about it for this treatment for this specific problem. Let me give a quick summary. In this video, our treatment is based on some greedy strategy. So we always subtract nearest power of 2 to n, and then do the update and counting. So if we realize this strategy, so actually the procedure is very simple or straightforward, right? So we get the powers involved, and then we get the nearest one, and then we do the update of m, and then we do the counting. That's it, right? So that's about it for this video. If you found the explanation here useful, you are welcome to follow up our channel in YouTube and share these videos with your friends or more people, so that these videos can be of use to more people. Thank you.